Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over selective precipitation. So selective precipitation, what is that? That's where you would like to have, you start with a mixture of ions and you want to remove one ion without removing the other. So you want to precipitate one ion so it's out of solution, it becomes a solid and you can remove it really easily and then leave the other ion in the solution. So that would be a way of precipitating out one thing without precipitating out the other. So we're selective. We're choosing what to precipitate out and leaving the other behind. So here's an example. So let's say you have some seawater. We know that seawater contains magnesium and calcium at this level here. So here we have the concentration of magnesium in your seawater, 0.059 molar. And here we have the molarity or concentration of your calcium in seawater. And so we want to precipitate one without the other. And so the first thing we're going to want to look at is their KSPs. So notice here that magnesium hydroxide has a KSP of 2.06 times 10 to the negative 13. And calcium hydroxide has a KSP of 4.68 times 10 to the negative 6. So remember, because these two have the same stoichiometry as far as dissolution goes, remember, so magnesium hydroxide, when it dissolves, will give you magnesium and two hydroxides. So that's three ions from one formula unit of your magnesium hydroxide. And calcium is the same thing, right? So you dissolve this, calcium will give you two hydroxides and one calcium ion. So that's three ions from one formula as well. So they have the same dissolution or dissociation stoichiometry. So you can compare the KSPs to indicate like the solubility of these. And so you can see that because calcium hydroxide has a higher KSP, the solubility is much higher here than here. So this isn't very soluble compared to this. Okay, so how could we selectively remove one or the other? Well, since your magnesium hydroxide is so much less soluble, right, this is going to precipitate out with less concentration than this. In order to get this to precipitate out, you'd have to up the concentration of your ions a bit before it'll precipitate out. This one, since the KSP is so low and therefore the solubility is so low here, it doesn't take very much ions to get this to precipitate out. So what we could do is we can find some sort of ion that will precipitate out this one at a low concentration and therefore leave this ion behind, right? So we want to get rid of magnesium or calcium, so magnesium doesn't take a whole lot, right? So if I could add hydroxide, right? So since magnesium hydroxide has such a low KSP and calcium hydroxide has a higher KSP, then all I need to do is add a hydroxide ion to my sulfide, excuse me. Sorry about that. Light again. Okay, so all I need to do is add a hydroxide ion at low concentrations, and that will cause the magnesium hydroxide to precipitate out first, leaving the calcium behind, because calcium hydroxide will not precipitate out until I raise the concentration a bit more, right? So what I can use then is a soluble hydroxide, KOH or NaOH. These are soluble hydroxides. They're very soluble in water, so they're not going to precipitate out. So I can dissolve these in my seawater. That's going to release the OH minus, the hydroxide ion. And then I can add a little bit and slowly raise the concentration of my hydroxide in order to precipitate out the magnesium hydroxide first, reach the point at which this will precipitate out first, and leave that behind. And so what I want to do is I want to compare the Q with the KSP in order to determine what the concentration is that's going to trigger the precipitation of one or the other. So that's how you do a selective precipitation. Now, in order to do a selective precipitation, one of the key things you need to keep in mind is that the difference in the KSPs of the required selective precipitation, the two things you are comparing, or the three things, or whatever it is you're comparing, they must differ by at least a factor of 1,000, 10 to the 3. So they have to be at least a factor of 1,000 difference between the KSPs. If the difference is less than that, then the selective precipitation is not going to work. Okay, so in other videos, I will do example problems where you can show you how to solve by selective precipitation. But this is the concept, and I hope this has clarified everything for you. I hope this is helpful. If you enjoyed this video, if this cleared anything up for you, please, by all means, hit that like button, subscribe to my channel, hit that notification bell right up there, and also put a comment down in the comment section below. Let me know what you think, and if you've got any questions, I would love to hear from you. Thanks for joining me, and have a great day.